Well, welcome to this latest edition of Thinking Aloud. And today I am joined by Paul Jennings from Aldas. Paul and I have known each other for some considerable time, not just personally, but through reputation. And Paul is the founder of Aldas. First of all, welcome, Paul. Nice to see you. I've written a little introduction for you, Paul, which I hope you're going to like. I hope I don't over flatter you. Okay. Paul, founder of Aldas, and is widely recognised as the longest served air tightness consultant and tester in the UK. That accounts for nearly 40 years of experience. And he's been at the forefront of building performance and helping the construction industry understand how air tightness not only affects energy efficiency, but also reflects the way buildings are actually built. He originated the concept of the Airtightness Champion. He developed the practical 12 steps to air tightness approach. He's been enabling UK contractors to reliably deliver air tightness and Passivhaus and other low energy projects for years. And Paul has trained countless architects, builders, technicians, and delivered loads of on-site practical sessions, spoken at international Passivhaus conferences in Germany, Vancouver, and in the UK, and has been involved in the majority of UK Passivhaus projects in some capacity. He's also known, if you need more, he's got a keen interest in co-housing and straw bale building. He was previously a director of the UK Cohousing Network, as well as 4 local co-housing projects in the Southwest, which blend his technical expertise and insight into how people and communities interact with buildings. Paul is known for being candid, opinionated, I can vouch for that, and full of practical stories. The kind that remind us that real life buildings performance doesn't always match the theory on paper. Paul, there's so much we can talk about, but in thinking aloud, what we tend to focus on is not necessarily, although we'll include it, obviously, the technical details, but the context in which it sits and how people view it, think of it, and interpret it. So, yeah, welcome. Oh, Paul, have I just lost you on the video? Are you there, Paul?
Yeah.
Sorry, I've just lost your video. Technical glitches, and we've hardly got going. There you go. Perfect. Thank you. So listen, let's begin at the beginning. To quote A.A. Milne, you were amongst the UK's earliest air tightness testers, if not the first. Take us back to those early days and what sparked your interest, because this was at the time when introducing this concept to a construction industry, you were doing it to an industry that never heard of this. So take us back to when that was and how you got involved.
Well, at that point, there was a certain amount of testing being done by organisations like the Electricity Research Council or, British Gas's technical department. Not very much, but there was a bit. And then I was in the fortunate position, I'd finished my degree and I was then working for an energy charity in London, based in King's Cross. And the GLC, the first edition of the London mayoral system with Ken, basically decided it wanted to promote energy efficiency in buildings as a means to improve health, reduce fuel poverty, and generate employment. London Energy and Employment Network. And they basically funded us to start doing air tightness testing. And they paid for equipment, they paid for people to come over from Canada to train us, which is where I got my relationship with Vetchtech, who is the test equipment that I use. And that was the early 90s. And we spent a lot of years going around, mostly social housing in London, testing individual properties, testing blocks, looking for what could be done and what was not working. And there was quite a lot of learning in there. One thing we discovered, which was a surprise, was that we had a H block in Hackney that had an air tightness of below 2 when we tested it. And we discovered that was because they'd just replaced the critical leaky single glazed windows with new UPVC. They had concrete floors and roofs, and it had wet plaster blockwork. Not surprising it was very airtight, and not surprising that 2 weeks later they had mold. And what this led to eventually, and it took a little while, was a policy for a lot of councils in London, especially in London, that they would do an air tightness test before they replace windows.
Was this did this sort of flush out the relationship between air tightness and ventilation at a very early stage?
No, because I'm afraid to say that in most of those council blocks, tower blocks or low rise, the ventilation was rubbish and not maintained and not working properly.
Yeah, I mean, I'm intrigued to know what sort of levels of air tightness you were uncovering. I mean, you've got an example of one there that was particularly airtight, but presumably there were an awful lot that were incredibly leaky.
Well, no, that's not true. Not incredibly leaky. Leaky, sure. But I mean, most of the social housing was in blocks. So you don't have suspended timber floors by and large, right? You don't, even if you did have, you don't any longer have sash windows and you don't usually have open fires. Excuse me. So fundamentally, they'd meet current building regs.
Wow.
Now,
Okay.
the ones that were worse were the new build stuff coming in the noughties and O's that was, you know, lots of plasterboard on dabs, voids that connect. Yeah.
Yeah.
Actually the start of use of plasterboard created a significant negative effect upon air tightness in the UK.
So what? Just going back to the beginning. So what was the reasoning and the thinking behind them appointing you and setting up this air tightness thing? What were they trying to find out?
Well, if you remember, by that stage in North America, they had these schemes where they would go and test dwellings and they would improve them to avoid the cost of new power stations and new distribution grids. Right. So there was a whole model there of benefiting households and avoiding expenditure for the state or the electricity utility.
So they made that obviously the straightforward connection between more efficient housing stock equals less power generated equals less cost to the occupants and less expenditure in terms of generation. Right. Okay.
But I mean, at the other thing is, of course, even at say an air tightness of 7 or 8, in poorly heated, unaffordable dwellings, you're going to get condensation and mold, and there are health effects.
Yeah.
I mean, Caroline Lucas years ago did papers about how much the NHS could save by improving housing, and it's a tragedy and it's a criminal. Well, you couldn't say it's criminal, but it's a black mark upon UK governments that have never taken that work forward.
Yeah. No, it is a shame, isn't it? So so they started off, and this is in the 90s, okay, and you're starting off and looking at this, and then when did they just as a sort of slight digression, but there was nothing in the building regs about air tightness at that time on a building? How long did it then take before that was even introduced? I know we'll come on to this probably in a bit.
Well,
But
I mean, before it went into the building regs in 2002 in Part L, firstly for non-domestic with testing, but also for air tightness in domestic, you just didn't have to test.
yeah,
Um, But before that, there had been a limited number of people, quite a few academics, quite a few architects who wanted to do tests because they wanted to improve their own houses
yeah.
or their own dwellings. We had quite a lot of university professors or lecturers who were getting their dwellings approved because they saw the writing was on the wall, really. You
So
know.
you got your in the 90s into this through this scheme to look at it, and then so when did this become, and how did you manage to play your part in turning this into a sort of a feature of building? In other words, a requirement of building to assess, to look at, and to deliver air tightness, because it's it intrigues me that the transition has taken a long time. I mean, it's actually not taken, the great scheme of things, it's not taken a long time. We're only talking about 30, 40 years ago, but it has accelerated, hasn't it? So when did you begin to see that pickup, and how did you actually encourage that to be more codified in terms of delivering buildings?
We were just testing. We weren't policy geeks, or we didn't
But you
have
were
any.
informing policy, weren't you? I mean, that the reason you
Yeah.
were there was to inform
Well, I
policy.
mean, I remember in the early days, it wasn't me, but a colleague went to do a demonstration test for Cecil Parkinson when he was energy minister,
Right.
but didn't seem to make any difference, and I don't think Richard enjoyed the experience. But that kind of stuff. We were doing that and trying to make a difference, make a contribution. Um, but the main thing I think was in the appreciation in local authorities that you had to take a holistic approach to improving buildings. If you improved the airtightness and didn't tackle the ventilation, you get more condensation and mold. I mean, remember in those days, in the late 90s, you could go along to test a council flat and there'd be 10 air bricks because every time the tenant complained about mold, they stuck a new air brick in, right? Ludicrous. Not holistic, not thinking ahead at all. Um, and I'm sure there's still some of that around, but fortunately they're mostly gone. And of course, the tenants, the residents, very quickly learned that a bit of cling film would close off an air brick.
So I mean that kind of leads on to sort of interpretation, isn't it? So it's not airtightness isn't really just a technical metric. It's often a sign of how well a project is understood. So how have you what have you learned about how builders and architects and clients interpret the delivery of airtightness? I mean, from the early years until now,
Well, it has absolutely changed. In the early years, in the late, um, well, before 2010, when it had gone into the building regs for dwellings, for sample dwellings, right? Most builders thought the air tightness was a pain in the arse and they'd do anything they could to get around it. So they'd
yeah.
basically do one, they're building an estate of 50 or 100 units. They'd do one to a high standard. And they'd say to building control, well, this is the only one that's ready. You'll have to test that one.
So they game the system basically.
Yeah, they gamed the system. Absolutely. And, even at the extremes of brown envelopes flying around.
I don't want to know about those.
Sorry?
I don't want to know about any brown envelopes. No, but I'm sure that was this predominantly you think driven by a lack of understanding of what was trying to be achieved. It was just another annoying thing that they had to do.
Yeah, yeah. It's the same short-termism. Get the dwelling finished, get the whatever it is, the stage payment, applied for, all the rest of it, and the fact that the quality is suffering and isn't, is being ignored was irrelevant.
Well, I mean, so we've talked about this before, but if and I know you have a slightly different view of me on this one, but if builders if the trades, let's just call them, do what they're told to do, in other words, they're given clear instructions, that's where you begin to unpick this, don't you? Because I think the meal analogy that we've used before, which is if somebody else is writing the menu and buying, and giving you the specification for the ingredients, what they're not doing is cooking it. But they're also, as you rightly point out every time I bloody mention this, is that they're also not suffering the consequence of whether it's healthy or not for their body, because it's not their body. But is that part of it? Is that the linkage was part of the problem, that everybody effectively did the job to their point of exit, and that was what they did, and they had no concern for the sort of the joined up thinking and the consequences?
Well,
Is that what was driving it?
There was no joined up thinking.
Right.
There was no thinking that at the end of defects, does this dwelling suffer from condensation and mold?
Does it pass is what they ask. Can I get this
Did it
signed off and
pass?
get my money?
Can I get a certificate? And I mean the common conversation, especially on certain builders, was, "Oh, you come to site, great. Can you give us a certificate?" "Oh no, don't bother doing a test. We don't care about the test. We just want the certificate."
It just reminds me of I'm sure this is not true, but it's wonderful. As my father used to tell me when I first started driving, this was back in the 1970s, for goodness sake, that there was a garage locally that did MOTs by post. You just spoke to Mr. Sumner or whatever his name is and gave him a few quid and then it arrived.
Yeah.
So I think, so the design, so it wasn't linked up, the design compliance, delivery, trade, craft skill, outcomes.
Yeah, and with the building regs, the Part L only requiring sample testing, weren't typically 1 out of 10 if you had 10 of a type, then it was inevitable that most of them wouldn't be to the same standard. I mean, I used to say I could go round major housing estates with a thermographic camera and I could tell you which were the ones that were tested. I could see the difference.
But yeah,
And
invisible to the
I
naked eye, but
apart from my allergic reaction to lawyers, I always thought that I could make a living by putting a card to your letterbox saying, "Are you worried about your heating? Would you like to sue your builder and or your building control? We can give you the evidence."
I mean, I think that the where I'm sort of headed with this is that one of the things I think I'm most impressed about in terms of what we use as a business at Eco Merchant when we're talking to our clients and customers is the 12 steps, because it gives you a logical, sensible path explained sensibly that says, at least, and it gives you a mechanism to connect them all together. Okay. So tell it, when did you first think of it? I mean, it seems to me that it's kind of obvious that if the whole thing was just completely disconnected, then with no mechanism to report or feedback, any outcome was acceptable, more or less, within the broad confines. So you decided to codify this with others into the 12 steps. When did you do that? That was mid
That was
2000s?
that was basically, and well, we tested the first two passive house projects in the UK in 2007, and that was where I so clearly saw the difference,
Mm,
and that was what led to that document being prepared. And it's changed over the years. It's iterated, it's modified, updated, but I stand by it. Because basically, if you want good air tightness, you can't assume it will happen because it won't.
mm,
Although occasionally it will, of course. If you build a like Chelsea Barracks, the development Chelsea Barracks, it's concrete slab floors, it's good triple glazing, and it's plastered block work. Well, if you can't make that airtight, you really should go home and do something
well,
else.
so I think it's fairly interesting, isn't it, that I mean, I live in an old building that was built in 1805, and it's solid wall and it's wet plastered directly to the masonry, and that's not the bit that
One day I'll test it.
no, please don't, Paul. It'll be bloody appalling. There's a fireplace in every room. There's lots of things that let the building down, but inherently the fabric is pretty airtight, simply by its nature. Um, so, but going back to 12 steps, where did the 12 steps start? So I'm just trying to visualize them in my mind's eye, but assuming the ambition of making a building airtight, talk us through the 12 steps and why some of the key elements are there, because I think it's
Well,
important to identify that it is almost like a procedure, isn't it? It's a
yeah,
path
it
to
is. It's
follow.
a roadmap. Yeah. Well, I mean, the first thing is, well, what's your target?
Mm,
Because if your target is only building regulations, well, you're probably not going to bother.
mm,
If your target is passive house or going anywhere near it, certainly as soon as you're using mechanical ventilation, heat recovery, you should have a concern about air tightness because you want the building to work.
mm,
One of the things I find very distressing is when I go along to test refurbished buildings with an MVHR system, I have to tell them it's a complete waste of money because the
mm,
building is so leaky, it's not recovering heat.
mm,
So, which is always distressing for the builder and the client. Um, but anyway, so what's the target? So the target at the extreme end was passive house, although now you can go even further than that. You know, the absolute common passive house target is an air change rate of zero point 0.6 air changes at 50 pascals. All right, but we're starting to see some architects, some builders going for zero point 0.3
mm,
because they know they can do it, and if they can do better air tightness, they need less insulation.
mm. That's an
Which
interesting one.
yeah, there's an argument for that. Of course, you've got to make sure you deliver it.
Yeah. Yeah, hence the 12 steps.
Yeah, yeah.
There was a
So
reasonable chance it'll
you
come
you set
unstuck.
your target, then you basically got to say, well, how are we going to do this air tightness? What's our what I call the air barrier strategy? So, concrete's a good air barrier, glass is a good air barrier. But if you've got a window in a concrete wall, then you've got to seal between the two. And that's the weakness. I mean, it's a fundamental truth that most air tightness is established by the basic ingredients. Plasterboard is airtight. It's just the holes you cut in it for your light switch, your electric sockets, your connections to cable TV. They're not, and it doesn't take long to compromise it. And then the whole classic thing of you're plasterboarding a kitchen, but well, you never bother going down to the ground behind the units. Why would you?
Yeah.
But that leaves you a, well, I don't know, 4 inch, 100 mil commonly gap behind those units.
So
And then you drill a hole for the waste pipe through the wall and you don't bother sealing that up.
why wasn't this getting done? Because is it where's the disconnect? Where's this coming undone in the system? Because presumably you would assume that the architect would have known that the plaster has to extend beyond. Or are we going to start blaming everybody here and attributing? I mean, is that? I mean, nowadays I think it is different. I think there's plenty of people who are very well aware of this. But when you first did this, your 12 steps were first addressed at who? Was it architects you were mainly focusing the 12 steps on and specify?
Well, I mean, my outlet of communication at that point was the AECB and
Right.
Building for a Future magazine, Keith Hall's magazine. So, that was where it got disseminated. And of course, there were key players, firms like Archetype, Andrew Yates, Bob Pruitt, who really took it on board, um, and even told me how to improve it at times, which, fair enough. Um, but that was, I mean, and truth is, I don't know. I put it out there, but I didn't know. Often I didn't know who was using it and how they were using it, were they paying any attention? The larger the builder, the less likely they were to pay attention.
Yeah. So I presume that when you first started this with the 12 steps and it highlighted some of the gaps and some of the areas that needed to be filled in, managed, maintained, or whatever, that was obviously taken on board by people who understood this and got this, but it was still not. I mean, it was still very, very niche at the time, wasn't it? I mean, these buildings were few and far between. So the rest of us were all still buying and living in energy inefficient housing stock because we weren't improving the airtightness of the buildings, or new builds were being built still at an appallingly low standard. Because when, I mean, it was only just recently that the air changes in the building regs got reduced again, didn't it, from 10 to 8?
Yeah.
I mean, it's one of the things that intrigues me about this, when we're talking.
But let's be clear, right? 8 air changes, right, which is a pressure of 50 pascals. So that's about the same as a 20-mile-an-hour wind. So that means every 8 minutes, the air in your property has gone with whatever heat it's got in it, right?
Yeah,
Every 8 minutes.
yeah. I mean, I'm reminded of the Future of Housing film that you're on with that very unfortunate lady who was wondering why her bills were so excessive, and you explained it to her in those terms. And basically, every however long it was in the particular case of her house, all the energy, all the air is being stripped out of your house. So one of the things I found useful when somebody was explaining to me, was that to visualize the aggregated gaps in a building. Okay, so at building regs as they stand now, the aggregated gaps in the building that would allow you to meet regs about the size of an ATM, which is a pretty sizable hole, like leaving out a whole window.
Yeah, remember it does vary with the size of the building.
Yeah, it varies with the size, but I think that was based on an 80 square meter
Yeah.
building. But the equivalent passive would be a credit card size. Aggregated gaps would be credit card size. And then I think you've been involved with Larch Corner, was it?
Larch Corner.
Where the aggregated gap you could have fit was a penny.
Yeah, well, the most airtight dwelling in the UK,
Yeah,
near Stratford-on-Avon, yeah, which was basically cross-laminated timber, which is easy to make airtight. It
yeah.
really is, although it was helped by the well, I think it'd be fair to say obsessive compulsive self-builder who basically had the windows installed by what was then Green Building Store, who were never, no, sorry, not Green Building. No, Green Building Store, who are not bad. I mean, different name now, but he went down and retaped every window.
This is the kind of person who tapes all the staples after the.
No, that was a particular Canadian project. That's very rare, although it did come across it on time. But usually that was being done because you'd had some membrane installed badly. Because if you staple a membrane, the membrane's the best membranes have markings to show you where to staple.
Mm.
But it also says you've got to get the staple properly in. And what you don't want to be doing is hammering the staple to get it in, because as soon as you apply a hammer to a membrane, you've trashed the air tightness.
Yeah. So I mean, just going back to the 12 steps and what you were sort of, where it could be applied. So there's a reasonable assumption that much older housing stock, the fabric itself, apart from chimneys, windows, and doors, etc., the floor, the walls, etc., would be relatively airtight, and you could see the way to improve that. So you new windows, new doors, address the issues at ceiling height as well with the roof. And then you've got modern new build, where you can start from scratch and you can choose a build system that is more airtight friendly. But then you're left with basically the bulk of British housing, which is what's in the middle, which we've already built to a standard which we're living in, where the air tightness is dreadful, and the energy efficiency is really low.
Yeah. And what does the government do? It builds nuclear power stations, complete bloody nonsense, at vast cost and small employment, when they could be refitting, well, it would need to be tens of thousands, even hundreds of thousands of existing dwellings, and do it effectively, do it by street or by area, so you cut the costs. Because the cost, when we see a lot of committed people who spend a lot of money fixing their homes. And if it was done on an area basis, if it was done under a national scheme, they'd probably cost them half as much.
Yeah.
And all credit to them, they're spending their money to make a difference and to demonstrate what's practical. But, the idiots in government don't help.
Are there particular building types that are easier to increase the energy efficiency on in the sort of housing stock that you experience? I mean, let's not forget, for example, many social landlords, there is the increased dynamic with a social landlord that they own the stock, and long-term efficiency is actually financially beneficial to them. But they're still owners of plenty of sort of, Victorian and Edwardian brick-built houses or masonry houses, etc. And then you can go through the decades. One of the things I did on one of our blogs was just to look at the type and style of build over the decades, 70s, 80s, 90s, etc. But are there buildings that, where we really did, where they were built for the constructor's efficiency and to deliver on the numbers rather than energy efficiency and airtightness?
Yeah, mostly this century.
Right. So it's the modern
seriously,
way of building.
There are acres of, relatively young existing houses around towns like Northampton or Gloucester or wherever, that basically they're so badly done. They've got lots of voids. They're plasterboard and Metsec framing and all the rest of it, and they're not ultimately fixable. They're not robust enough. You're going to basically end up at some point knocking them down, turning them into terraces to improve the built form, and reusing the concrete slabs. That's what's going to have to happen. Whereas if those Victorian Edwardian houses, there's something solid there.
Yeah.
Something you can work from. Now, you don't want suspended timber floors anymore, for sure. So that's an issue. And things like spotlights that connect into an unheated roof space, that's a no-no. But the potential is there. And the problem really is that, it's kind of an obvious thing to say, but because of the way we own and change our houses, every property is unique, effectively. Right? So you can say, well, this property here, we're going to do A, B, C, D, E. We can't do F, we can't do G. Right? But that's what you need to be working on. How do you aggregate building works, improvement works, to make them A, more cost effective, and B, robust?
Yeah.
And that's one of the things that annoys me for years. Why do we not have a national database, right, of improvement projects, what's worked, what hasn't worked? Why are the lessons being learnt in, when architects meet up down the pub after the ACB conference, for example? Why aren't they being inculcated into architects when they go through the schools and the universities?
So, does how does the when you go just to revisit the 12 steps, how does that help link architects, designers, specifiers, site managers, etc., contractors? How does that then link into connecting them so that the ambitions are maintained and the delivery is actually what they design?
Well, the 12 steps splits really. You've got 12 steps to get a design that's workable. So you've got, what's the target? What's the barrier strategy? What are the specifications? What are the drawings? You know, what's the check of the air tightness? Is it consistent? Is it joined up? But at that point, you've got a design that will work. And that then goes to a contractor. And the first thing after that is an Air Tightness Champions course. If you're trying to do good air tightness, you have to have properly trained people, responsible people looking after the construction on site. Because I'm afraid it's absolutely routine to go to a site and they've just changed the position of an extract fan, or they've installed an extra, or whatever they've done, but usually with no thought to air tightness. I mean, one of the things I quote commonly is a Passivhaus project near Stansted Airport. When we started testing, we discovered that every property had 3 holes for the gas boiler flue.
And did anybody explain why?
No, nobody explained why.
Closer.
Nobody took responsibility. They just bodged it up, and I mean, it passed in the end, of course. But you do wonder how robust and long-lasting those remedial works are going to be.
Yeah, I'm intrigued by this because obviously, how did people receive this idea of an Airtightness Champion? Because an awful lot of people are just going to look at it and think another bloody cost. I've now got to have someone. They've got to learn this stuff. And then they're going to be telling people what you can and can't do on site. And also the other thing is was this partly because everything that needed to be done couldn't just be drawn? It had to be interpreted and delivered on site. So no matter how good the drawings were outlining, the airtightness strategy and where everything was, etc., it still has to be interpreted.
Well, I mean, it's certainly true that quality of drawings and detailing for airtightness has massively improved over the last, I don't know, call it 20 years. I mean, it wasn't deliberately done like that, but it was just we knew what worked, and we needed people keeping an eye on airtightness on site, day in, day out. It wasn't enough for an architect to go to site once a fortnight. If they had the skills to look for airtightness, great, but they might not have them. And even if they did, they weren't there often enough. And as for building control, with the whole, decimation really of building control making any significant impact on quality on site, that was a waste of time, and they couldn't afford me. I mean, I do remember early projects, big projects, an archive project up north where they said, "Oh, can we have you on site for 6 months?" And I laughed at them. I really did. You can't afford it.
I thought you were cheap, Paul. So this whole thing about matching what gets designed to what gets delivered and the Airtightness Champion. So nowadays you've got, is it more prevalent nowadays that you find Airtightness Champions? Have we kind of got there now with passive projects, etc., or are there? Because I'm also intrigued about the psychology of this, because if I was the client, I would be no doubt well reassured if there was an Airtightness Champion, somebody who was looking after the outcome on my behalf, making sure that I didn't have to go back and take all the plasterboard off the walls or remove the kitchen in order to fix a leak to meet the target that we're aiming for. So who's the champion there to reassure most?
Well,
or is it just a compliance thing?
Okay. What the champion is really there for is to avoid liquidated damages because your project runs over because you got the airtightness wrong.
So in other words,
that's what it's really about. It's risk avoidance, and that's what the big passive house contractors, the Kiers, the Wilmot Dixons, they've learned. This is risk prevention,
right?
Because you look at the costs of getting projects wrong and running weeks, months late because you screw up the air tightness, it's a nightmare.
I mean, we've all got apocryphal stories. I think that that we can go into, but so effectively, what this is it kind of doesn't matter to a lot of people that if it is just a compliance issue, if they get a more energy efficient building that behaves well, it doesn't matter if that's achieved simply through stick rather than carrot, does it?
Well, I
But
mean, the thing is, you have to remember, um, air tightness does a lots of things, right? It represents quality. And if you get the air tightness wrong, then the one thing you guarantee them, you got moisture movement through your building. And if you think almost all of our buildings, certainly not domestic buildings, have significant amounts of wood. That might be wood insulation in the walls, uh, or it's,
roof,
just wood joists in the roof.
yeah,
And I've done work with Bill Bordas looking at condensation that's occurring in roof spaces because the building is more airtight and it's getting into the roof space.
yeah,
So there was a conversation about could we change the standard airtightness test to include testing leakage through the roof space. It hasn't gone anywhere yet, but these things do take significant amount of time. But it's airtightness shows quality, and if your airtightness is wrong, your moisture will be wrong.
right,
And of course, the other thing that's going on with climate change, the effect of external driving rain is becoming more important. If your external skin, whether it's cavity or solid, is soaked more often for longer and dries out less, then what's happening to moisture internally?
yeah. So the whole you can sort of see how people require and want this to be simplified because this is an enormous, it could be and can be an enormously complex topic. Yeah, but in
Yep.
essence, what you're doing is to use the analogy that many people use is this is associating or linking a Gore-Tex outer shell with a fleece when you're on the hill. The insulation works better with air tightness, and the air tightness works in concert with the insulation to give you a warm, comfortable shell, and then you don't suffer from the consequences of moisture buildup. So I mean, I'm just thinking about any projects we can sort of even refer to where you get the theory right, and then there are issues, or it changes when you get on site. So where it didn't link all the way through. I think you've mentioned one. I think one you've been talking to me about recently was a passive swimming pool that you did, if I remember rightly. So where you have basically you've been talking to the architects, the building designers, etc., and you've got wonderful drawings, and everything looks as though it's going to be absolutely fine. And then yet there are issues on site, or the delivery doesn't quite match the design. Where was that pool? Where was that swimming pool one?
That was St Sidwell's in Exeter,
Oh right, yes, of course.
which was, it's a great success. It's a Passivhaus certified swimming pool and leisure centre that is operating at about 10% of the running costs, the utility energy costs of the other earlier building nearby. And it's a game changer. Nobody in the UK now is going to build a new swimming pool and leisure centre without at least looking at doing Passivhaus or maybe ACB standard for air tightness, because it works. But even on that project, the at somehow it had some vertical smoke shafts to vent the building if there was a fire, and they got overlooked. So right near the end of the project, we had to go in
Where
and
were they overlooked? Were they overlooked in the original drawings and for the
no,
building?
they were shown on the drawings, but they were overlooked in thinking about airtightness.
All right, okay,
So basically, they were blockwork shafts with no airtightness.
right,
So, literally, we were called in late to test them, and once we'd tested them, they then had to break a hole in because they're only about a meter squared. They're not very big, and then basically make a parge coat over 6 or 8 stories
wow.
internally. Right? That's not something you want to be doing in the last couple of months of a prestige premium project.
Yeah,
But still there. I had an inquiry about testing AOV shafts again, last week.
But once that problem was solved, you ended up with a really fantastic building in terms of air tightness performance.
Well, it was already a fantastic building for airtight performance, but the problem was that the smoke shafts wouldn't work. They wouldn't isolate smoke from the building,
Right.
right? So it's not just about energy efficiency in airtights, it's also about smoke control, you know, moisture control, smoke control. I mean, even in some blocks of flats you worry about, or I worry about, maybe the client doesn't, vermin. Is if it's so poorly airtight, can you actually stop cockroaches moving around, for example?
Mm. So, I mean, I'm quite intrigued by the perception of the people that you talk to. I mean, aside from the fact that they're already interested in air tightness and they want to explore it, but how do people generally perceive air tightness? Are they convinced by the data, or do visual things help them, or case studies help them? And how, I mean, how do you deal with clients with that to discuss the topic of air tightness when you're dealing with them? What are you encountering that they actually see and think?
Well, I mean, if you're actually doing a test on whether it's, an end user, someone who's going to live in a house, or it's the builder, often the first airtightness test is transformational. A builder who hasn't seen an airtightness test will, they'll be gobsmacked by what they discover. Things that leak, things that can make a difference. Just saying to people, yeah, this air tightness membrane here, yeah, well, you see where it's been scraped by plasterboard, it's now leaking.
Hmm.
That crack around that uh, pipe going in through the floor slab, that's leaking. You know, it's and especially if the conditions are right, which basically means if you've got a temperature difference of 10 degrees or more, the thermal imaging is amazing at showing up stuff.
So, I mean, I'm going to complain on this one. You and I visited one of your sites some years ago.
The one in Lewis, yeah.
No, it was down on the coast near Eastbourne. Do you remember? There
Oh,
was a
okay.
refurb, yeah, and you basically just wound me up. Just said we were, so it was positive pressure. So you had the thermal camera from outside. Temperature difference was what you wanted it, 12 to 15 degrees, I believe, and he'd had the heating on. And although you had the camera in your hand and I couldn't see the screen because you were probably hiding it from me, he was saying, "Where do you think the leakage is?" I was going around thinking, well, they've got dormer windows, they've got this, that, and the other. I got this. I got this when you showed me, because when you looked at the pictures, there was a wall that was rendered that looked like a crossword puzzle, and to the naked eye, it was just a white rendered wall. But all the mortar joints were weak and leaking. They were all yellow, and some of the areas where I was fairly keen that there should be leakage, there wasn't. Some of the lead flashing around the dormers, for example, perfectly okay, showing no heat. That I do agree with you. I think that's really compelling. Tell me about thermal imaging, because I think I think more people should. I mean, I think it should be more widely used. I think part of the issue is the cost of the cameras, because they're ruinously expensive, aren't they? But I think
Well, they've come down significantly.
yeah. So
Um,
just tell us how you would use a thermal camera to give somebody the kind of jolt into understanding it.
well, in an ideal world, which doesn't always happen, we do 3 surveys,
Right.
right? We get the client to heat the building, often overnight, or heat it all day, and then we're going along after sunset, several hours after sunset. Because one of the things you have to appreciate, the sun on a building dramatically changes the thermal um, image you collect. So you don't want the sun. So
Mm.
it's actually a very antisocial activity doing thermal imaging, because you're normally on site at 2 a.m.
I know. I remember when you asked me to come down and join you at some ludicrous hour in the morning.
Yeah. But anyway, so your first survey is you're looking from the outside before you've applied any pressure. So you're looking for heat loss. And that could be warm air rising just through gaps, typically at the eaves, or it could be issues with the insulation, maybe missing insulation. But anyway, you do that. and then you turn your door fan on and you pressurize the building, so you blow air in. So now you're trying to drive hot air out through those gaps and cracks. And what that hot air does is heats up around where it comes out. And you give it a little while because there's a lag in the system, but after 20 minutes or half an hour, you can re-look at the same places and spot the differences,
Mm.
right? And the difference is where air is leaking. You're driving hot air out, it's heating the surface. You can see it. In that particular house we looked at, there was this big crack through the render at the
Yeah, I
bottom
remember.
corner of a window, but it wasn't visible on the surface. But when
Um,
you looked at it thermally,
it
you know,
boy was it looked like a lightning strike. I mean,
yeah,
there's I'm happy to share, by the way, if anybody is gets in touch with it. I'm happy to share the daylight photo and the thermal imaging. It was really quite compelling. Yeah. What did the client think when you showed the client the checkerboard wall and the leaks? There was also another leak on that building, if I remember rightly, which was on the patio. The patio was glowing yellow and red, wasn't it?
yeah.
On that particular
Well,
one.
there were a lot of issues on that building. You know, do you remember the rear door, the
Oh,
lower level door? That was horrendous. You could
it, it,
see.
it it's worth mentioning the client was very into this and was very ambitious to have this done and was looking at an Enefit style refurb of the house, weren't
Hmm.
they? But I think inevitably he probably got to come to the conclusion that actually demolition would probably be the best option.
Well, I
it,
think I think it was pass the problem on to somebody else.
it was one of those sort of construction college Bob and Ted show you how not to do it sort of videos with just about everything you pointed the camera at
Mm.
that you thought was okay was awful. Yeah, but I think that as well. I mean, the more than any written description or design will tell you, this kind of showing people that the illustration of changes people understanding, basically
Yeah,
fundamentally changes people understanding of the product. So how do you do this with other clients? Do you show them?
yeah, yeah, yeah. No, the routine is, yeah, no, absolutely. We do it as many times as people will pay us to do it. And we're looking at uh, external leakage without pressure, external leakage with pressure, spot the difference, and
Yeah.
then internal leakage when that point we're depressurizing, and that you'll see a different set of leakage then, because they don't necessarily join up very obviously. You might see leakage around a window on the outside, but on the inside it's happening under the windowsill.
I mean, to my mind, where this is really useful, which is no doubt where it actually happens, is that it allows people to buy into this, whether you're trade or whether you're architect, because it's reality. It's showing you what actually happens. Obviously, the interesting thing to do would be then to refurbish the property and then redo it all again to show that these problems have been eliminated. But as every time you learn that, the next time you go to a building, you'd be looking at it thinking, hang on a minute, maybe I shouldn't make this presumption about this, or maybe when I'm doing this work, I should work in this particular way. So that all helps to this sort of accrued knowledge, which in turn, I suppose, maybe you're seeing some of this is that then with a more informed and engaged group of people in the industry, they tell more people and more people tell more people. And you end up with this form of sort of social proof where people think, at least I can talk to Dave about it. He's done one of these buildings, etc. That's quite an interesting dynamic about how this spreads.
Yeah. Yeah,
Uh,
it spreads through, presentations to ACB or Passivhaus conference, or indeed presentations, CPD sessions for architects, typically,
I mean, it's
architects.
I went on a. I'm going to name names. They deserve a plug, but Pro Climber, or some people say Pro Clima. Um, they did a course that I went on in Ireland, and it was attended by a lot of English architects. And the one thing that we all remembered was it was related to the size of roll of membrane working in a roof space. And so, like 3 meter membranes, just no,
Yeah,
impossible to handle, especially if you've got scaffolding up there. Some guy on the course one of the trades had knocked up this little wooden coffin made out of waste timber, which was just a tiny bit larger than the roll and had a 2x4 or a 2x2 around the outside. And he dropped the membrane in, pulling it out from underneath, like you would a sort of, cling film dispenser.
yeah,
Put that on the platform, pulled out what he needed, and then ran his craft knife along the timber to cut it. along the dotted line on the membrane. And everybody went, wow, that's just going to make it so much easier. So you can put the roll in the coffin, hand it onto the top of the scaffold, and the guys can just pull it out like you're pulling out tin foil in the kitchen.
Yeah.
Or just that one little tip.
Yeah, but and the width is such that one person can hold the corners.
Exactly. Yeah. And then like you say, you've got your staple marks and everything else. So at least the manufacturers are thinking about this really sensibly to make life practically very easy.
Yeah.
But I'm kind of more convinced, Paul, I don't know whether you'd agree, that actually practical delivery is really, really important. Getting the trades to make up for some of the missed bits, which may be unintentional, the junctions, the connections. Especially in a refurb, the amount of questions we get asked about, for example, embedded joists in masonry, okay, between floors. You're refurbishing a building. How the hell do you deal with that? Okay, so on that base, just on that, are there any products that you want to pick out that have made your life easier?
Well, I mean,
what changed things?
Well, I mean, when Airtight OSB came in, first with Duralis and then SmartPly and others, that made a huge difference, because before that we were using ordinary OSB, and bluntly, the UK sourced OSB was not as good as the German OSB for airtightness. So basically, I remember, testing houses and saying, well, I'm sorry, you got to cover all this OSB with airtight membrane.
Yeah.
And builders did not like it. I remember.
So they're taking 2 bottles into the shower instead of one. They just want to take one.
It is exactly. I remember one near Brecon. I said to me, look, you've got all this, and because you can see it with smoke. You can, if you've got OSB, or indeed the same applies to blockwork. If you think it's leaking, you stick a metre squared bit of polythene on. Make sure it's carefully sealed around the edges, and then you depressurize. If it bulges, it's leaking. It's very simple.
You did, yeah. I mean, it's interesting. The Duralis Unilin product, which is an airtight board, part of their advertising is a wonderful YouTube video of them with OSB on one and the Duralis on the other. And the OSB board, they rub them both with soapy water and then pressurize the back, and the OSB board blows bubbles.
Yes.
It's one of these wonderful visual demonstrations. So, but the take up of airtight specific OSB or P5 board is pretty bloody low.
Well, you would know rather than me, but
yeah,
I'm surprised. Yeah.
So OSB not being airtight. Actually, think about it. There's a whole list that you did, I think, somewhere, which we could share with people.
Well, I mean,
not airtight.
The airtight OSB was the first thing. Then became the airtightness paints.
Yeah.
Blow-proof was the first, which I always like best because it changes colour. Which is such a useful thing. It changes colour when it's dry.
Yeah.
Which is a good thing to know, because the trouble is, if it's wet and you turn the fan on, you make holes in it.
I know you've done that to us after all that time getting blow-proof into the country and through its BBA, and then you go and bubble it up. Oddly enough, the Duxford Museum, which was incredibly airtight, that was all done in white because it was an archive, and that was a particular problem we had to address when that was being delivered with the contractor. Yeah, but I think there was a game. I do think that airtight membrane, liquid airtight membranes, was a game changer.
Yeah. No, absolutely.
And things like joist ends, just paint them. You can always apply the liquid in areas where fiddling around with tape and membrane is difficult.
Well, also, I mean, so common. We go to a site that's failed a couple of times, and there's bits of foam all over the place, and you basically just cut it back and apply airtightness paint over all of it.
I think it's a classic example, isn't it, of making it easy for people actually leads to adoption and use.
Yeah.
I mean, to be quite honest with you, apart from one instance that I can think of, but a story for another day, applying an airtightness liquid membrane to part of a building is about as difficult as putting a hat on.
Well, the example being the one where they diluted it.
Well, go on then. I'll tell you. Yeah, we went to a site where you tested it and it failed. And once we had the meeting in the site hut, the guy who'd put the paint on decided that he was going to defend himself by not admitting liability, but accusing the clerk of works for an instruction was, go easy with this stuff, it's damned expensive. So had only put a single coat on rather than two coats on, and it failed. Yeah, that was a really interesting dynamic, that one. But once it was on and it was done properly, it passed full time, and that was for retirement living homes.
Yeah,
Yeah, for the elderly.
I mean, one of the things that there's increasing awareness, particularly in the big contractors who are doing passive house, of the costs of downstream remedial works.
Yeah,
The costs of having to go back to a school or a leisure centre or a swimming pool to fix stuff that should have been fixed, could have been do it right first time, right?
yeah. I think
Do not rush.
if you're contractually obliged to deliver a building of a certain level of performance, it should deliver that performance.
Well, you should deliver better than that because the truth is, it will get worse over time. It will degrade. And what you don't want to be doing is at the end of defect saying, well, it fails now, fix it. You want some margin. It's why we say to people, if you're aiming for 0.6 air changes for Passivhaus, you want to get zero point 0.4 on a preliminary test because almost certainly the services will add some leakage as they go in.
Yeah. So we're sort of coming to the end of our time together. So just one last question, really, and then I've got a little thing that I do with everybody on each one of these casts. But where do you think this is going, Paul? Are we on the right track? Because I kind of get the feeling we are. It's just that it's a scaling issue now.
Well, it is a scaling issue, but there are factors coming that will make it harder. I mean, for example, just more extreme weather.
Right.
Right. At the moment, we generally worry about air tightness tests in February and March because it's too windy.
Right.
But what happens if it becomes December to May?
Well, I suppose the converse is true as well. Is what happens if daytime temperatures and nighttime temperatures don't vary more than a certain amount? If you've got nighttime temperatures of 21, 23 degrees, you might be go the other way, be too hot.
Well, yeah, that's true. Overheating. And also, well, I mean, of course, at the extreme is if the Gulf Stream disappears, then we're 8 or 9 degrees colder anyway. So, hey, I think there's definitely an argument for improving the quality of our housing stock. And, it will make it will reduce health inequalities. Why should people without enough money suffer because the people in government don't make the right choices for policy?
Yeah, I think the social side of it's really important to us as well. Is there does seem to be a sort of an inherent unfairness about this, although so we're always quite gleeful and happy to accept that the social housing is one of the areas where we see more improvement, more activity, more action, and some of the best case studies are coming from social housing, and it's principally to do with the dynamic of ownership and responsibility. They'll invest in their buildings long term. As if you're just building a house for somebody else, stuff it. Compliance is good enough. Paul, we could go on and on, but I've got at the end of every one of these little sessions, I always ask my guests 3 questions. One, and so I'm going to ask them to you and see what you say. But one is recommend a good read. So book, article, resource that had a profound impact on the way you think about your approach to what you do, or that changed your perspective on what you do.
Well, I went to speak at a Passivhaus conference in Vancouver a few years ago and was introduced to a whole pile of resources, technical literature from Canadians doing air tightness. And of course, they'd been doing it earlier than us, and they have a more extreme climate. So they got more incentive. So that was useful. And then in the UK, the resources provided by the ACB and the Passivhaus Trust, there's not really, I wouldn't say there's a how to do it manual in the UK.
No one's written the Air Tightness Bible yet. Yeah.
No, I mean we did with Sarah Price and Alex Baines, we did the Passivhaus Guide for Air Tightness, which now needs updating, I think.
No, but a thundering good read, I might add. Yeah.
Yeah. Yeah.
I was very impressed with that.
Yeah.
So and then let's have a piece of advice from you. Maybe something that you got to a bit late, you might have wished you'd known earlier, that you'd pass on to anybody who's involved in delivering air tightness. If that's their bag, what's the principal piece of advice you give someone?
Don't rush.
Take your time, yeah?
Yeah, take your time. I've seen any number of air tightness tapes peel off because the surfaces weren't prepared.
Right.
Right? It weren't, because air tightness tape sticks to dust really well.
Just the rest doesn't. We'll conclude with just one moment in your career where you suffered some sort of behavioural shift that changed the way your work went and your career went. Was it that meeting? Was it that meeting right at the beginning when you went on they started with the air tightness in London, and you suddenly thought, "Hang on a minute, there's something in this"?
No, no, not really. No, I wasn't um, introspective enough to think about that. I just was head down, get on with it. The thing that made the biggest difference was losing my driving license, actually,
Wow.
which changed how I had to behave. I couldn't drive along with a van and all the rest of it. I had to um, identify the key pieces of equipment and figure out how to get there.
So something completely external that
Yeah,
just changed everything what you
absolutely.
did. Well, it's all turned out wonderful because you have a wonderful reputation, and I know lots about the excellent work you've done, and I've absolutely loved this. I've thoroughly enjoyed it. Thank you so much for coming on, Paul. It's been
Pleasure.
a pleasure having you, and happy testing into the future. Well, no. um, so that concludes this episode of Thinking Aloud, everyone. Thank you very much for listening to it, and hopefully we'll see you again next time. Thank you.